Hi, hello guys, and this is Subhashini, currently studying ECE second year, and today's session is about the topic multiplexer. Okay, let's go into our topic. What is multiplexer? A multiplexer is a combinational circuit that has many data inputs and single output depending on control or select inputs. For n input lines, selection lines are required or equivalently for 2n input lines and n selection lines are needed. Multiplexer are also known as n-to-1 selectors, parallel to serial converters, many-to-one circuits, and universal logic circuits. Generally, multiplexer is called as a MUX. Okay. There are types of multiplexers, and they are um, 2 is to 1 mux, 4 is to 1 mux, 8 is to 1 mux, and 16 is to 1 mux. So the name itself indicates 2 is to 1. 2 is to 1 means 2 input lines and 1 output lines. In a 2 is to 1 mux, there are 1 select lines. And in 4 is to 1 mux, 4 input lines and 2 select lines and 1 output lines. And in 8 is to 1, 8 input lines, 1 output lines and 3 select lines. And in 16 is to 1, 16 input lines, 1 output lines and 4 select lines. And these are the types of multiplexers, and in today's session we are going to see about the 4 is to 1 multiplexer. What is 4 is to 1 mux? In previous slide itself I told 4 is to 1. 4 means a 4 input and 1 output, and it has a 2 selection lines. So 4 to 1 multiplexer takes 4 inputs and directs a single selected input to output. It another combinational circuit that has a multiple binary inputs and 10 and 1 output. A 4 is to 1 mux as 4 input lines such as I0, I1, I2 and I3, and 2 select lines S0 and S1 and 1 output line Y. Okay, this is the block diagram of 4 is to 1 mux. In previous slide itself I told 4 means a 4 input lines. This is I0, I1, I2 and I3. These I0, I1, I2, I3 are 4 inputs and Y is the output, and S0, S1 are 2 select lines. Then the truth table. Coming to the truth table, when S0 is 0, S1 is a 0, the output should be I0. And when S0 is a 0, S1 is a 1, the output Y is a I1. And when S0 is a 1 and S1 is a 0, the output should be a I2. Similarly, when S0 is a 1, S1 is a 1 and the output should be a I3. And this is the final equation of the 4:1 mux. Coming to the circuit diagram, S0 and S1 are two select lines. I0, I1, I2 and I3 are the 4 inputs, and here Y is the output. Okay, this S0 and S1 here 2 NOT gates and 4 AND gates and 1 OR gate. Okay, the operations of 4:1 mux. When S1 is a 0 and S0 is a 0, the AND gate A is enabled and the AND gate B, C, D are disabled, so the output Y equal to I0. In the truth table itself I told when 0 and 0 condition, the output should be a I0 here, and 0, 1, B is enabled, so the output is Y equal to I1. And when input 1 and 0 The C is enable and the output y equal to I2, and similarly when S1 equal to 1 and S0 equal to 1 and the AND gate D is enable and the AND gates A, B, C are disabled and the output Y is I3. This is the operation of 4:1 mux. And the Verilog code. Mm, this is the module and we declaring as the name as a mux and the inputs A, B, C, D, S0, S1 are the inputs and Y is the output. So input A, B, C, D, S0 and S1 are the inputs and output Y, and we are assigning the condition Y output equal to S1, S0, D, C and S0, BA. This is the single condition we are writing here, and this is the end module for completing the Verilog code. And this is the output waveform. When we are giving here inputs, the output is this waveform. This is the 4:1 mux wave output waveform using a Vivado software. And the coming to the application of multiplexer, it is used as a data selector device. It is used in communication system to increase the efficiency of the system. It is used in the telephone network for integration of several audio signals on a single transmission line to maintain a large amount of data. Multiplexer are also used in the computer memory system. Multiplexer are also employed in a TV broadcasting systems. It is used in a satellite communication and a global positioning system GPS. It is also used in the programmable logic control system, and these are the some of the applications of multiplexers. So this is about the multiplexer, and in this session we see about the 4:1 mux. Thank you.